Hi, welcome to clickmyproject.com. Now we have to see the process of privacy preserving decision tree learning using Unrealized dataset. Here is the abstract of our process. Privacy preservation is important for machine learning and data mining. The aim of our project is to preserve privacy before the data are published, but the methods designed to protect private information often result in a trade-off, reduced utility of training samples. This project introduces a privacy preserving approach that can be applied to decision tree learning without loss of accuracy. It describes an approach to the preservation of privacy of collected data samples in cases where information from the sample database has been partially lost. This novel approach can be applied directly to the data storage as soon as the first sample is collected and converts the original sample datasets into a group of unrealized datasets. After the entire group of unrealized format is obtained, we can reconstruct the data and get the original data samples. At the same time, using C4.5 algorithm, an effective decision tree can be built directly from those unreal datasets. Using the approach, the privacy is achieved for each and every data sample. This method provides high security compared to previous decision tree learning methods. Here is the DFT of our process. First, dataset preprocessing. Here the data are collected and stored into the databases, then moved to unreleased data format. Here each and every data samples are collected from the database are split into equal parts, thereby adding dummy values to each and every parts of the original datasets. So thereby obtain a group of scientist data. After obtaining the group of scientist data using the C4.5 algorithm, the entropy and gain calculations are done. After calculating the gain value, moves to the decision tree generation. Here, which attribute has a high gain value? It is denoted as a root node. The other attributes are denoted as a child nodes based on the gain value. This process is repeated for the group of scientist data. Then the process is completed for all scientist data. Hereafter, only the data owner reconstructing the original data. Otherwise, it is not possible to reconstructing the original data. So thereby achieving high security compared to other approaches. Let's see the demo of our process. Here, select the dataset. Then the dataset is successfully loaded into the database. Then moves to next process. Here by clicking view button, original datasets are viewed. Then moves to the next process. Here we have to create the scientist data. So the copy of the original data created successfully. So the scientist copy created. Then moves to process. Here by clicking the scientist data, the original data set is split into equal parts with the dummy values. So by clicking scientist data, so scientist data are created. Here the original data is split into 7 equal parts. So this data also contain the dummy values. So select any one of the type. Not to select. So the scientist data are successfully viewed. Then moves to the next process. Here we calculate the entropy and gain using ID3 algorithm. So the entropy is calculated for each and every scientist data. This also gain value is calculated based on the entropy of all scientist data. Then moves to the C4.5 algorithm. The C4.5 algorithm and ID3 algorithm is also same as for entropy and gain calculation, but C4.5 algorithm is best compared to ID3. It supposes discrete value attributes. So we have to see the efficiency of our C4.5 algorithm. Here the entropy is calculated for all scientist data and also gain value is calculated for all scientist data. Then moves to the next process. Here, after successfully converting the scientist data, the decision tree is built for each and every scientist data. So select any one of the scientist data, the decision tree is generated for the corresponding scientist data. So here the decision tree is generated. The first attributes, the denoted as outlook, temperature, humidity, wind. So the outlook attributes has a high gain value, so that is denoted as a root node. So the temperature, humidity, wind, it has the low gain value compared to the previous value. So it is denoted as a child nodes. So the values are denoted as a distinct values of these leaf nodes. These values are denoted as distinct values of these leaf nodes. So the decision tree is successfully created. Then moves to the next process. Here the data owner wants to reconstruct the original data means if they have the entire scientist data. So we have to reconstruct the entire scientist data are listed. So the entire scientist data are collected to one table. So even merge data means all scientist data are successfully merged into one data. So by clicking reconstruct, the dummy values are removed and thereby retrieve the original information. Then move to the next. Here, by clicking the show button, the reconstructed data are successfully viewed. So the reconstructed data are created by removing dummy values from the scientist data. Here the time and accuracy graph shows the efficiency of our C4.5 algorithm. Here the time graph denotes our C4.5 algorithm is best compared to ID3 algorithm for generating the scientist data. The accuracy rate denotes the loss of accuracy rate comparison between ID3 algorithm and C4.5 algorithm. Here our C4.5 algorithm provides the best accuracy results. In conclusion, we introduce a new privacy preserving approach via dataset complementation, which confirms the utility of training datasets for decision tree learning. This approach converts the sample datasets into some unreal format, such that any original data is not reconstructible without the entire sets of scientist data. And also here we use the ID3 algorithm and C4.5 algorithm. The ID3 algorithm is used for entropy and gain calculation, and also C4.5 algorithm is also used for entropy and gain calculation. But C4.5 algorithm supports discrete value attributes also. That's why it provides much more high efficiency compared to our ID3 algorithm. Thank you.